Here we are, our fourth week of remote learning. We're starting section 6.3 on radicals and rational exponents. So we've talked about radicals being square root sign, but they actually involve more than just a square root. So we're going to actually kind of break down this title and think about what if I had this problem, 2 to the third power. We know that's our exponent, and by now you know, for a while you guys have known, that 2 to the third power is equal to 2 times 2 times 2, which is equal to 8. Well, if we were to work backwards, how can we start with 8 and get an answer of 2 cubed? Well, 2 cubed, that equals 8, can be found by finding the cube root of 8. So this radical sign, what we've seen before, was without any root there. Everything was a square root that we were working with before. We're trying to find what times itself equals that value. Well, more than just square roots, there could be cube roots. There could be fourth roots, fifth roots, or any kind of root. So we can call it like the nth root, any number. So if we have something like the cube root, that means what number times itself 3 times would get us that answer. Well, I kind of just did it out for you right there. The cube root of 8 would equal 2. So let's try a different one. What if we had the cube root of 64? So think, okay, what number times itself 3 times would equal 64? So it's kind of like a guess and check. There isn't really a set formula to follow, but we know it's an even number, the last digit there. So our answer is going to actually be an even number. We know it's going to be higher than 2, and we could try 6 and see what 6 times 6 times 6, does that equal 64? Well, 6 times 6 is 36, and then if I multiply 36 times 6, it's going to be much higher than 64. So then what if we try 4? If we see, what's 4 times 4 times 4? 4 times 4 is 16. 16 times 4 does come out to be 64. So the cube root of 64 does equal just 4. Final answer would be 4. Cube root of 64 is 4. What about the fourth root of 81? Now we have an odd number under the radical sign, so it's going to actually be an odd answer. And if we think of what can go into 81. We know 9 can go into 81. 9 times 9 is 81, but we want a number multiplied by itself 4 times. So think, what can go into 9? That's odd, 3. So if we try it, does that work? 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. It does work. So the fourth root of 81 is 3. So all these problems that I just modeled are finding radicals, simplifying radicals. And now we're going to look at rational exponents. So we've worked already with exponents. So what makes an exponent rational? Well, remember, rational numbers are any numbers that can be written as fraction. So in this section, when we're mentioning rational exponents, we're looking at base numbers that have fractions for exponents. So let's take a look. If we have, say, 400 to the power of 1/2, it's not a normal exponent, it's a fraction. So this would be considered a number with a rational exponent. Anything that's a fraction or even a decimal would be considered a rational exponent. And then when we have just the whole numbers, those are our regular exponents, like what we've been working with before. I said whole numbers, but anything positive or negative, like what we use in scientific notation. So how do you solve with a rational exponent? Or how do you simplify that? What does it mean? There's a 1 in the numerator, there's a 2 in the denominator. Each part of the fraction, the numerator and the denominator, play a role when simplifying. The denominator represents what root you want to take this base number of. So because our denominator is 2, we want to take just the square root of 400, because 2 just represents the square root. We don't normally have to write the 2. Without it, that means the same thing. Square root of 4 or 2, or not 4, 400. They're equivalent. So square root of 400, what does that come out to be? Well, we know the square root of 4 is 2, and then the square root of 400, well, sometimes people think, oh, 2 zeros, I need 2 zeros in my answer. But if it's 200, that means 200 times 200 would be 400. And that's not true. But 20 times 20, that's 400. So the square root of 400 is 20. So we took care of our denominator here. The denominator represents what root we're going to take under the radical. And now what about the numerator? The numerator represents to what power our answer has to be raised. So because it's a numerator of 1, we're just going to take our base and raise it to a power of 1. So the final answer just stays 20. Anytime the numerator is 1, we're actually just going to take the root based on the denominator. So the denominator is our root, and the numerator is our exponent for what we get when we simplify that radical. So let's try one more example to kind of clear that up. But the final answer for 400 to the power of 1/2 would equal 20. Or again, this is our rational exponent. We could write it in radical form. Radical form is when you use the radical sign, and we could actually include the 1 right there. So we'd solve inside the parentheses first, and then raise our answer to the first power. All right, so another example that we can look at is if we have, I'll do one that's not a numerator of 1. So let's say 16 to the power of 3/4. So again, remember our denominator represents what root we're going to take. We're going to take the 4th root of 16, and then whatever that answer is, we're going to raise it to the 3rd power. So these two expressions are equal, they're equivalent. This one's in rational exponent form because it has an exponent. This one's considered radical form because it has the radical sign in it. So it's kind of where our title comes from. We're working with radicals and rational exponents. We have, again, rational exponent form, radical form. So to simplify this, we got to find the 4th root of 16. Remember, we're multiplying some number by itself 4 times to get 16. So it's kind of a small number here. Our answer is going to probably be small. And it comes out to be 2. Because 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So if I multiply 2 by itself 4 times, I get 16. And then I got to raise that to the 3rd power because it comes from right there, which was our numerator. So 2 cubed, 2 times 2 times 2, gets us 8. So this rational exponent can simplify to a final answer of 8. So what you're going to be working on is rewriting some problems given in this form, rewrite them to be in radical form. Or if you're given a problem in radical form, can you just rewrite it with a rational exponent? And then other ones, can you actually simplify them out? So I will post these notes on Google Classroom, and I will be available for any questions at noon on Zoom. All right, good luck.